Out there in the quiet of space, countless planets circle their stars. We're getting pretty good at finding them. We've spotted thousands. We've found blistering hot Jupiters, frozen wastelands, and rocky worlds not so different from our own. But in all that searching, we're really hoping to find just one thing. A sign. A hint that we're not the only ones asking if anybody else is out there. For all of human history, the universe has met that question with silence. But that might be changing. Because in the atmosphere of a planet over 100 light-years away, astronomers have found a hint of something that really shouldn't exist. It's a gas, a very specific gas that on our own world is overwhelmingly linked to one thing: life. This is the story of a discovery that could change everything, but it's also a story about the agonizing, brilliant, and potentially frustrating process of science itself. We might be on the verge of rewriting our place in the cosmos, or we might be looking at another cosmic false alarm. Our story begins about 124 light-years from Earth, in the constellation of Leo. There, a small, cool star hosts a planet called K2-18B. Now this isn't Earth's twin. It's a much larger world, classified as a sub-Neptune. It has about 8.6 times the mass of Earth and a radius about 2.6 times larger. It belongs to a category of planets we don't have in our solar system, which scientists have given a very cool name: Hycean worlds, a mix of the words hydrogen and ocean. These are theoretical planets believed to have deep global oceans of liquid water hidden under a thick, hydrogen-rich atmosphere. K2-18B has been on our watch list for years because it orbits its star right in the middle of the habitable zone, that sweet spot where temperatures could be just right for liquid water. The Hubble Space Telescope first gave us a hint, finding evidence of water vapor in its atmosphere. But the real investigation kicked off with the James Webb Space Telescope. In 2023, JWST stared at K2-18B and found significant traces of carbon-bearing molecules, including methane and carbon dioxide. The evidence was building that this giant alien world might just have the right ingredients for life. But it was the next find that sent a jolt through the scientific community. To understand what they found, you have to know how we study these planets. We can't see them directly, they're just too small and far away. Instead, we wait for the planet to pass in front of its star, an event called a transit. When it does, a tiny amount of starlight filters through the planet's atmosphere. Like light passing through a stained glass window, the gases in that atmosphere absorb very specific colors, or wavelengths, of light. By looking at which colors are missing from the starlight that reaches us, we can work out the chemical fingerprint of that planet's air. JWST used its powerful instruments to analyze that filtered starlight. It confirmed the methane and carbon dioxide. But it also picked up a faint, tentative signal that was completely unexpected, possibly dimethyl sulfide, or DMS. On Earth, DMS is a big deal. It's the molecule largely responsible for the familiar smell of the sea, produced almost entirely by tiny marine life like phytoplankton. On our world, we found no major geological or chemical process that produces this gas in large amounts. It's made by living things. So, finding even a hint of it on another world is like discovering a footprint on a supposedly untouched beach. It's one of the most exciting potential biosignatures, a chemical sign of life that scientists have been searching for. The initial analysis suggested it could be present in concentrations much higher than on Earth. The discovery was electrifying, but in science, and especially when you're talking about alien life, extraordinary claims demand extraordinary evidence. The scientific community immediately started doing what it does best, trying to prove the finding wrong. First, is the signal of DMS even real? The detection is incredibly difficult. It's a weak signal buried in noisy data from a telescope looking at a planet trillions of miles away. The first hint in 2023 was tentative. Follow-up observations with a different instrument on JWST in 2024 and 2025 strengthened the case, with the research team reporting a 3 sigma level of statistical significance. That means there's only about a 0.3% chance the signal is a random fluke. That sounds pretty good, but for a claim this big, scientists want to see a 5 sigma standard, where the chance of a random error is less than 1 in a million. We're not there yet. Some scientists have pushed back, suggesting the signal might be another molecule, like methane, that absorbs light at a similar wavelength. One group reanalyzed the data and argued there wasn't enough evidence to claim a detection at all. This isn't a failure. It's the scientific process working exactly as it should. It's a tough, rigorous debate to get to the truth. Even if the DMS is real, does it have to be life? We now know there are non-biological ways to create this molecule. It's been found in the gas and dust between stars and even on comets. It's possible that unknown chemical reactions in K2-18B's strange atmosphere are making the gas, or that comets are delivering it. The team behind the discovery argues these sources likely can't explain the amount of DMS they seem to be seeing, but the possibility is still there. This is the difficult part of the search. We've had false alarms before, like the tantalizing but still debated signal of phosphine on Venus. K2-18B could be another one, so let's just take a step back and think about what this means. We're at a crossroads. Down one path is a discovery that could fundamentally change how we see ourselves in the universe. If this gas is real, and it's being made by life, it would mean that we are not alone. It would mean that in the dark, silent oceans of a world 124 light-years away, something is alive. The cosmos wouldn't be a sterile void, but a place filled with potential. It would be the single greatest discovery in history. But to be sure, every other possibility has to be ruled out. Before we can even begin to talk about aliens, the evidence has to be airtight. The burden of proof is enormous, and for good reason. It's easy to get carried away and see what you want to see in a faint flicker of data. That's why the scientific community is being so careful, checking every number and questioning every assumption. The only thing worse than not finding life would be to announce it and be wrong. So where do we go from here? The answer is simple: we need more data. The case of the mystery gas on K2-18B is far from over. The research team has called for more observation time with the James Webb Space Telescope, perhaps 16 to 24 hours more. They need to stare at the planet for longer, watch it transit more times, to build up a stronger, clearer signal from the noise. They'll use JWST's MIRI instrument, which sees in a different range of light, to get an independent confirmation and help tell DMS apart from any imposter molecules. This new data will be critical. It could either boost the signal to that gold standard 5 sigma level of certainty, giving us the most compelling evidence for life beyond Earth ever found, or it could cause the signal to fade away, revealing it was a statistical ghost or the mark of a more ordinary chemical process. But even if the DMS signal disappears, this work isn't a failure. The techniques being perfected on K2-18B are pushing the absolute limits of our technology. We are learning how to search for life on these bizarre Hycean worlds. Every planet we study, whether it's alive or not, teaches us something and refines our search for the next one. Right now, K2-18B is an incredible puzzle. It's a world of huge possibility, holding a clue that could be the start of a new chapter for humanity or just a fascinating cosmic riddle. We're like detectives, following a faint trail of clues across an ocean of space. We don't have the answer yet, but for the first time, the question, "Are we alone?" isn't just for philosophers anymore. It's now a testable scientific question. And with tools like JWST, we finally have what we need to start looking for an answer. What do you think is going on over at K2-18B? Is it a thriving ocean world? Or are we just seeing some weird chemistry we haven't discovered yet? Let us know what you think in the comments. And if you want to follow this amazing story and other mysteries from deep space, make sure to subscribe and turn on notifications. The universe is full of secrets, and we're here to uncover them together. Thanks for watching.